welcome Emin. Emin is from Spacelift, a senior solutions architect, and will be supporting me with this demo today to highlight Spacelift and raise awareness around what Spacelift is. I only have a month or so of experience with Spacelift, so it's really great to have that support for Spacelift to offer that support. We'll look at more detail what we're going to do, how we're going to use this session, and then we're going to look at OpenTofu quickly, a bit of a glance at what OpenTofu is if you haven't heard of it before. We're going to talk about why we would use a control plane for IAC, which is what Spacelift is. We'll have a look at some of the differences between Spacelift and Terraform. We'll look at what our demo may look like, although I'm not sure that I've populated that slide. And then Emin will give us some stories around customer impact that he's witnessed within clients adopting Spacelift. And then we'll go to the demo, look at policy as code within Spacelift, drift detection and auditing. And then we'll open up to a Q&A for both myself, but I imagine primarily Emin, to answer questions around Spacelift. So by the end of this session, hopefully you'll understand what Spacelift is, what a control plane is, see how it adds automation, guardrails and auditability. You'll see the live demo, recognize what Spacelift looks like, and hear directly from Spacelift on the real world impact that Spacelift has had on clients. OpenTofu. OpenTofu is an open source tool for managing cloud infrastructure as code. It's a community-driven fork of Terraform, created after Terraform moved away from the fully open source license. Because it's a drop-in replacement for Terraform, the commands and language are the same, and teams already using Terraform can switch with little to no friction. The benefit is that OpenTofu is governed under the Open Source Foundation, ensuring that it stays transparent, it's vendor neutral, and it's community controlled. In short, basically, OpenTofu lets you automate the provisioning and management of infrastructure at scale in a way that's reliable, auditable, and is future-proofed for the open source community. So that's what OpenTofu is. This is a brief look at what the differences of features are between OpenTofu and the Terraform CLI, which is what it's forked from. You can see that OpenTofu has some features that Terraform doesn't have, and Terraform has some features that OpenTofu doesn't have. Obviously, the key driver for adoption for OpenTofu is usually the licensing that changed with the HashiCorp acquisition by IBM, but there are now other features as well. Let's look at what a control plane is, what Spacelift is, and what HCP Terraform is. When we talk about control plane in infrastructure, we mean the layer that manages and orchestrates how resources are provisioned and governed. You can think of it as the data plane is where the actual resources live, your VMs, databases, networks, etc. in AWS, Azure, GCP. The control plane is the brain that decides what should exist, when it should change, and who's allowed to change it. Without a control plane, teams often run infrastructure commands directly from laptops or CI pipelines, and that works at a small scale, but it really grows in complexity as things scale up. Also, the issue with that is there's no centralized audit control. You don't know who ran what or when, certainly not without a lot of manual effort. This leads to kind of inconsistent enforcement as well. One engineer might apply a policy and another might bypass that policy by accident. It's really difficult to scale when many teams are managing multiple environments and trying to coordinate within one environment or another without having a control plane. So yeah, control planes solve this by centralizing and orchestrating everything. Every infrastructure change is funneled through a single system that applies guardrails and automation before it touches any cloud provider. So you'll see the key benefits are kind of policy enforcement. So you can make rules like no public access to S3 buckets and ensure that's applied every time someone creates an S3 bucket. You can create access control to delegate who can run what and who can deploy where. Auditability, you have a great audit trail of every run, approval, drift remediation. It's all logged for compliance reasons. Consistency is obviously one of the key outcomes of using infrastructure as code, keeping all environments following the same workflow, whether it's dev staging or prod. Scale, you can support dozens of teams, hundreds even, without each one having to reinvent how infrastructure changes are made. So in practice, a control plane sits between your IAC definitions, like the OpenTofu and or Terraform, and the cloud APIs. It doesn't replace the IAC tool. OpenTofu still exists, Terraform is still there. The cloud APIs provision the resources, and it enhances your governance and automation through that. That's why modern infrastructure teams use platforms like Spacelift. They transform their IAC from ad hoc scripts, which they started out with, into more reliable, scalable ones. That's far safer for the business, especially when compliance is a key. Some of the differences between Spacelift and HCP Terraform, aka Terraform Cloud, where you can see that they both have similar features. Obviously, the core of it is the same. It's a control plane for infrastructure as code. Spacelift has more supported IAC engines, as you can see on these two slides. Demo time. The key things I want to look at within Spacelift are going to be policies and drift detection. So looking at how you can secure your infrastructure as code with rego policies in Spacelift, and looking at how Spacelift can detect drift and how it can auto remediate if needed. So this is the Spacelift dashboard. As you can see, we've got various options on the left, which I will go through the key ones now. So Spacelift has the concept of stacks, and stacks represent the environment to which code will be deployed to. Each stack can be connected to VCS repository with your OpenTofu or Terraform code. It will run that on a worker and deploy the infrastructure to AWS or your cloud provider or wherever it may be. It's got a registry that it supports. I have nothing to show in there at the moment. And here we've got policies and worker pools, what we'll be looking at today. So most of you engineers will be familiar with the concept of workers and custom workers based on various CI systems or Terraform Cloud. The idea is that Spacelift provide public workers, and the public worker pool is here, and you can run your jobs on their servers. That means that you don't have to provision your own infrastructure, and it's good when you're starting out or getting to know Spacelift. But you can also create your own custom workers in your own environment, so within your own AWS account or your own cloud account, wherever that is. This then enables you to be able to run those workloads more securely within a private network, giving it access based on IAM roles to resources to do the tasks that it needs to do, and not having to have those credentials stored in Spacelift or in the cloud insecurely. Custom workers also enable drift detection. Spacelift runs drift detection as a schedule, and that schedule runs on a private worker, can't be ran in the public worker pool. What that does is checks your infrastructure for drift, which we'll get into a bit later. We'll just take one look at source code here. So I mentioned that Spacelift integrates with your VCS, with GitLab, GitHub, or whatever it may be. Here I've got an integration to my GitLab, which enables us to create stacks associated with those particular repositories within there. And what I have done is, when you create a VCS integration, you specify the URL, etc., and it gives you a webhook for GitLab to add to your repository. So whenever you push code to your repository, that webhook triggers to Spacelift, so Spacelift knows that there's been a VCS change. I'm not sure, Emin, whether that's the same flow for all VCS or if there's different integrations.
Different integrations, because every VCS has different type of connection configuration, actually. For example, for GitHub, you can install a GitHub application to your GitHub org, and then via that app, you can connect to your Spacelift account. Every VCS integration is different. Yeah.
Thank you. Yeah, so I've configured this webhook in GitLab to enable that functionality. So I've got this basic Terraform OpenTofu code, which creates an S3 bucket here. Currently it's insecure because it's allowing public access, and we'll look at how we can secure this or flag this within Spacelift a bit later on. So that's source code, that's worker pools. So there are instructions on Spacelift's documentation on how to configure worker pools. If I remember rightly, it's provision the instance or compute that you want it to run on and run a few commands using a secret generated by the worker. I think you provide it a CSR and it generates you a certificate and a key that you can put onto the server. I didn't do that today, so I can't remember off the top of my head. So next we'll look at stacks. So stacks are the kind of core of what we'll be looking at. It's effectively jobs. It's, I guess, similar to workspaces within or projects within HCP Terraform. It's workspaces. Yeah. Excellent. So if we go into this lunch and learn one, I've already set up the repository to be connected to this stack. When you create a stack here, you give it a name and select the space, add labels, descriptions, select the VCS that you want it to connect to. As I said, you can select the branch and the repository. From that integration, you can specify the project root. So if your infrastructure code that you're wanting to manage isn't in the root of the repository, if it's in, say, an infrastructure folder or a Terraform folder or something like that, you specify that there. Then you select the vendor that you're going to use, whether it's OpenTofu and Terraform, Pulumi, CloudFormation, Kubernetes, Terragrunt, or Ansible. I've only had a look at the OpenTofu Terraform stuff. I haven't looked at the other vendors yet. I'm very interested to, and hopefully I'll get around to that soon. And then you create your stack. So that was the main settings you need. You can also select the worker that it needs. So set it to the AWS worker pool, which is the workers that are defined and created in AWS. And all these other various settings here, auto deploy, very handy. These add hooks, they're pretty cool. I think they're similar to, is it run commands in HCP? I think it is.
I think so. Yeah.
So for each stage of the workflow, so when a stack is triggered, it will initialize, plan, apply, and it can obviously destroy. I'm not sure what the finally and performing is. Performing when it just kicks off?
No, it's for the tasks within the stack. So within the stack, we have 3 types of runs. Propose run, which is basically a plan run for you to review the plan changes. We also have a track run, which is basically the apply run to create the resources, right? We also have a task. These tasks are ad hoc commands you can run against your environments, against your stacks at any point in time on demand, right? Either it's a Linux command, or for example, if you want to run OpenTofu state or Terraform state commands, right? You can run them as a task against your stack. This is where the performing stage comes in.
Excellent. Okay. And these enable you to specify commands that can run before and after each of those stages, as you can see here. The cloud integrations, so that's pretty cool, and something I haven't set up yet is you can just integrate directly with your cloud provider to generate short-lived credentials to enable you to not even require your roles or access keys to be in Spacelift, and then you attach the policies. So at the moment I've just got 2 policies in here, context, and then you get to the summary here. So that's how you create a stack. But as I said, I've got one here already created and associated with that VCS. You can see here that I've made one run already. You can see the history. I ran this just before to create an S3 bucket, the S3 bucket that we saw in code. And the reason I created it prior to that was to highlight drift detection, which hopefully is ran. So if we look in here, we can see that I've created this S3 bucket in AWS, and here it is. But what I've done is I've set the versioning to enabled via the console, not in code. So something I shouldn't be able to do in a production environment, but something that is possible if you have misconfigured permissions, and is quite common, fortunately, is that people will go in and change things, especially in an emergency when there's fires everywhere and people are trying to figure out why systems are down. They'll go in and manually change things. That's not great. So what we can do on a stack level here is go to the scheduling tab and enable drift detection. You can see up here we can create different schedules. There's obviously drift detection's not there because I've already created it. I've scheduled this drift detection here to run every minute to reconcile any drift that it finds. Remind me where I go to view the drift detection. Is it under one of these?
Starting now. So if you go to the runs on the left-hand side, no, just under Terraform registry.
I see.
Yeah, so you should be able to add a filter there for the drift detection runs. Type. Yes, exactly. These are all your drift detection runs. And the most recent one is actually running.
Okay, so
yeah, so you can go into the run from there directly. If you click to that and go to run, click to go to run, right button. Yep, exactly. You'll be able to see the details.
okay.
So it shows you no changes right now. Maybe because the versioning is not catched by that. Maybe if you can change another parameter in the bucket.
Yeah, let's have a look.
Add another tag to the stack, to the bucket. I don't know.
Let's see. Yeah, I didn't actually set the versioning in code, so that would explain it.
Maybe
so
it is enabled by default with the S3 bucket resource. I don't know.
So that will run again in 60 seconds. Do you want to explain how drift detection works, Emin? Is that?
Of course, yeah. While we wait, I can definitely do that.
Thank you.
So basically, in drift detection, we check 2 things. First one is your desired state. Your desired state is going to be your Terraform state or OpenTofu state, right? Because that's what you have in your code, and that's what you want to manage your infrastructure resources. The second thing we check is the actual resource configuration, like the actual state of the resource itself, right, in the cloud provider account. And if we detect any drift between the 2, we inform you about that drift, and also we allow you to have that option to reconcile those changes. So what I mean by reconcile is you can revert those changes back to your desired state automatically with Spacelift's drift detection feature. But of course, some of the drifts, like maybe, let's say, in a downtime or when you're troubleshooting something, you want that drift detection, the drift to happen, like because you want to manually change something really quickly. So that's when you can disable that reconcile option and of course know about the drift itself. And maybe after that troubleshooting period, you can just go ahead and manually import some of the changes or revert some of the changes back to its original state. But with this drift detection feature, you'll be able to see what is drifted, what resource has actually a problem, a configuration change, etc.
Okay, I can't see that coming in yet.
Can you go back to the stack again? Because there's a run.
Oh, is this auto remediation?
Oh, probably, yeah. Can you scroll up to the changes? Let's see what it is. Exactly, yeah. It returns the tags to its original state, yeah.
Yeah,
so
when
basically
when I checked the auto remediation on the drift detection, what it does is it will automatically create a run to add that state back to the desired state and remove those changes.
Exactly.
Excellent. And then you can even have that to auto deploy, so it'll automatically revert the changes every time.
But of course it is dangerous. Like I said, if you're manually troubleshooting something, you don't want some of the changes to revert back automatically. So be cautious.
Yeah. I'm going to have to be quite quick with this because I've taken a lot of time already. So policies, you can define policies in Spacelift. There are various types of policies: approval, push, plan, trigger, notification policies. The push policies evaluate event that has been pushed, and you can decide using Rego code whether or not that push is going to run. In short, that's certainly what I use it for at the moment. A plan policy evaluates the results of a plan, and based on what you are going to create, destroy, or whatever, you can create rules based on that. So you can say, well, if it's going to do any deletions, no, don't allow it, or don't allow that deletion of this specific resource unless it's got these tags, various things like that. I don't know if you have any better examples, Emin.
Yeah, definitely. So I can give a couple of examples for every policy type. For example, for an approval policy, you can say if some of the security resources, like, I don't know, maybe IAM policies or security groups are going to change, or if someone's going to add a new resource to that group, you can require an approval from the security team for that deployment, right? You can have your role-based approvals for the deployment. For push policies, you can say if this commit is coming from Matt, just trigger the run. But if it's coming from Emin, just don't trigger the run, deny it. Maybe Emin's a junior engineer or an intern or something like that, right? Or for your plan policies, you can enforce tagging on resources. You can say, these are my required tags: name, environment, team, etc. And if anyone tries to create a resource, define a resource in Terraform without defining these tags, you can just automatically deny that run and let that engineer know about why it has failed with a message. Or you can entirely deny creation of some resource types. For example, if anyone wants to create an AWS IAM access key resource, right? You can deny that run automatically if you don't want your developers to do that kind of stuff in Terraform. For a trigger policy, you can create customized trigger options for the runs. For notification policy, I don't think it does require an explanation, but basically it allows you to configure notifications to various locations. Either it's email, either it's the Slack channel or a Teams channel, etc.
Excellent. Thank you very much for that. I'll just quickly show the audit trails. There they are. It logs everything, who did it, when they did it, what they did. It's just obviously key for a control plane system to be able to show that kind of information. So yeah, I said I'd show auditing. There it is. I'm going to have to cut the demo short, unfortunately.
One thing to add here, you can also configure these audit trail logs to send somewhere like a CM solution or something like that as well.
Yeah, absolutely. Ship it off to whatever system you're using for that. So with that, Emin, I think if we hand over to you, then we'll leave room for Q&A answers. Does that sound good to you?
Yes. There's already a question in the chat. Let me answer that first, and then we can go from there. So the first question what would be 3 to 5 reasons to use Spacelift over HCP or TFE? The first reason, we support multiple IAC tools, not just Terraform, including OpenTofu, CloudFormation, Plumi, Ansible. So it becomes a real control plane for managing different tools and different workflows from a single location, centralized location. And Spacelift has features to allow you to basically configure connections between those different workflows too. So we see multiple teams in various companies use different tools. For example, some teams can use Terraform to deploy the actual resources, but the other team can use Ansible to configure those resources, right? So we have features to connect those workflows together and maybe share information between those resources and create like an automated triggering mechanism between those workflows too. Right. This allows you to have more freedom. The second thing here is we have been using OPA and REGO policies for a long time, and OPA has become the security standard, which is recently added to the HCP platform and TFE. They were using Sentinel policies, but OPA gives you more freedom and more granularity when it comes to policies. The second question, what would be a recommended solution to automate configuring Spacelift? That's a great question, actually. So I don't like the UI myself for every platform. I like our UI because it's gorgeous, in my opinion, but I get what you mean by that. And we also, we are an API first product. So we use a GraphQL API in the backend. So you can directly interact with our platform using that API to create the stacks or the workers, all of the concepts we have in our platform. So, and you can also build your automation scripts around that manually using that API. Also, we have an OpenTofu / Terraform provider for Spacelift itself too. So you can manage your Spacelift resources with infrastructure as code, if that makes sense. And also, you can put that code into a Git repository, and you can also deploy that code through Spacelift too. We have a concept called administrative stacks. With that administrative stack, you can manage Spacelift with Spacelift, if that makes sense. And also you can have the same automation, just like any other cloud provider resource, have the same GitOps workflow for your Spacelift resources too, which is actually we recommend to our users. Make sense?
Yeah, thank you.
Back to some of the basics, and then I'll go from some of the use cases and maybe some user stories. So when you think about these control planes, just like I mentioned in the chat, these control planes act like an additional layer. But most of the time, you can think of these control planes as your CI/CD platforms for your IAC deployments, infrastructure as code deployments, right? We allow you to, of course, provision your resources, configure your resources, and govern your resources from a single platform. And the advantage of Spacelift, it is now a single pane of glass. Sorry about using a buzzword here, but it is really a single pane of glass to manage almost every infrastructure related resource from a centralized location. We focus on 5 main use cases. So the first one is called developer velocity. Developer velocity allows you to deploy fast and of course securely, and it allows you to have scalable deployments to achieve faster time to market, right? The second one is infrastructure governance. Matt showed you some of the policies here, right? It allows you to have more control and of course implement security guardrails around all of your deployments, right? So you can enforce policies across all teams and across all of your infrastructure resources. Cross-team collaboration, like I said, Spacelift is the one place for development platform, DevOps teams to manage their infrastructure resources. We also have some features to have that self-service implementation for your infrastructure resources too. So we have a feature called Blueprints, which allows you to configure templates for your developer teams. And those developers, maybe they don't have experience with infrastructure as code at all, and they just want infrastructure resources, right? Usually what they do here is they create a ticket to the platform team or the DevOps team, and the DevOps team configure the resources and deploy the resources for the devs. And when they are finished with the resource, it's also the responsibility of the DevOps team to maybe delete those resources afterwards to avoid like the cloud cost, right? So with our blueprint feature, the DevOps teams can create a template for their developers. They can give freedom to the developers to create their own infrastructure resources easily. And at the same time, the DevOps teams will have control over what they can deploy, basically, right? You can give that self-service to the dev teams too. The next use case here is, of course, infrastructure scalability. So basically, with Spacelift, you can expand automation beyond infrastructure provisioning here. Because you'll have visibility over the resources, you'll be able to configure and connect like multiple workflows together. Like I mentioned before, Terraform to Ansible or Terraform to Kubernetes, etc. You can configure all of that in Spacelift. It's not just an infrastructure provisioning platform, but it's infrastructure orchestration platform for you. The final use case here is cloud cost management. So most people don't care about this a lot, but it is really important when it comes to cloud because I've seen some companies like migrating off cloud these days just because of the cloud cost, right? But with Spacelift and with the tool called InfraCost, you can enforce cloud spend guardrails across all of your infrastructure. So you can create policies, and within those policies, you can create budgets for teams or maybe business units. And with those budgets, you can have more control and more granularity over the cost spendings for the infrastructure resources. When you look at the workflow of Spacelift, by the way, it is a basic GitOps workflow. I don't know if you're familiar with the GitOps tool. Maybe you know about Argo CD or Flux, even GitHub Actions, right? Basically, this is allowing you to have your Git repository as your single source of truth, right? You make all of your changes to your Git repository, you version control them. And we, as the additional layer, connect to your repositories via stacks. Those stacks, you can think of those stacks as your pipelines, right? As your deployment workflows, right? We trigger the automated runs for you. The advantage of Spacelift here is you don't have to define those pipelines yourselves. You don't have to have a pipeline YAML file in your Git repository to define the steps of the deployment workflow yourself, right? We do that for you. We automatically trigger the runs in certain conditions. For example, if you create a PR or MI, if you're using GitLab, right, we trigger the proposed runs, those planned runs for you, so you can review those changes and collaborate with your team members really easily. And once you approve them, once you merge those into your main branches, we trigger the apply runs, the track runs for you, and of course, create infrastructure resources, basically. This basic workflow can be extendable. For example, like we mentioned before, you can attach policies around those deployments to implement those security guardrails, right? Or if you want to manage different environments, if you have like different cloud provider accounts, different business units, different teams, etc., and if you want to create a separation between them, we have a concept called Spaces to allow you to have that multi-tenancy within your Spacelift account, and of course configure RBAC for your users based on those spaces too. So they can work on their own infrastructure without stepping on anyone else's toes. Our architecture is really simple. Basically, you have the IAC code, right? You push that code to the Git repo. It triggers the run in our platform. By the way, our platform either can be used as a SaaS platform, or we also have a self-hosted version too. So you can deploy the Spacelift control plane to your accounts too, right? And then that run gets assigned to a worker, a Spacelift worker, either public or private. Matt mentioned both. And basically, those workers handle the run for you. But I just want to talk about the private workers here a second, because when you think about these private workers, you deploy them to your environments and they act like a proxy between your environment and Spacelift control plane, basically, right? You can configure them either on top of a Linux machine, or you can run them inside a Kubernetes cluster as well. That's totally up to you. This allows you to have more configuration options because you will own these instances, you will own these workers, and you can configure the IAM permissions, the network connections, I don't know, the sizing of the instances, etc. yourself. We only care about the registered worker to your accounts. And that's how we calculate the concurrency as well, and that's how we calculate the pricing as well, which is fairly easy in my opinion. Some user stories. So if I remember correctly, they were on TFE, Terraform Enterprise, and they migrated all of their more than 3,000 workspaces to Spacelift self-hosted. And one of the key advantages of Spacelift for them was the fact that we support not just Terraform, but multiple IAC tools, because that allowed them to increase collaboration within their organization. And of course, the performance of the platform is, on one hand, is really important, but being able to give flexibility to the teams was really crucial for them. Because when you think about it, if you're using, let's say, I don't know, Kubernetes, for example, right? You're going to have another deployment platform for that. If you're using Terraform, you're going to have a deployment platform for that. If you're using Ansible, maybe you'll use AAP or AWX, right? That's another platform. So you basically start jumping from one tool to another, and being able to centrally manage all of those workflows, all of those deployment workflows from a single platform was really crucial for them. And the migration process was really easy. Why I say this? Because we also have a migration kit tool, which is an open source tool, by the way. It allows you to migrate your workspaces, all of those environment variables, integrations, all of that from TFC or TFE to Spacelift. So they were I know 3,000, 4,000 stacks of workspaces, it sounds a lot, but they were able to migrate all of that in a couple of weeks from TFE to Spacelift. So the transition was really smooth for them. I've seen some people configuring GitHub Actions or GitLab CI or even Jenkins to automate their IAC deployments as well. So you can think I can build this myself as well, right? But you have to put together a lot of different components and moving parts together to be able to have this kind of comprehensive deployment workflow option for you, right? You're going to have to maintain your pipeline, that's first. For example, for Terraform and OpenTofu, we also provide state management. No one talks about this, but state management can be a cumbersome job for some organizations. So with Spacelift, you can also manage your state files too, right? Automatically. So you don't have to worry about that. You don't have to worry about securing that S3 bucket or configuring the IAM permissions for that S3 bucket too. The other thing, policy management, and of course, third-party integrations, you would have to do it manually if you're using those generic CI/CD tools like GitHub Actions, GitLab CI, etc. We offer that for you. And most important thing, in my opinion, we offer you the visibility. Most of the time, people don't care about that a lot because we don't like UIs. We're a bunch of nerds, right? We are all a bunch of nerds, and we don't like to take a look at a dashboard or a UI. But it's great to have some sort of option to overview your entire infrastructure, overview your entire deployments, and of course, all of the resources and the connections between those resources. And of course, being able to audit who did what is also really important as well.
Thank you, Emin.